In this video, I'm just going to work through a couple of the methods of solving logarithmic equations or exponential equations. This will be a recap of some of the things we've seen. It'll also be a prelude to some of the homework that we have assigned. So the first problem I've just taken out of the notes packet, we had 7 raised to the power of x equals 80. Now we showed there's a couple of ways that we can go ahead and solve this. First method, what you see pictured here, has us rewrite this as a log equation. In other words, what we've done since we started working with logarithm and exponential equations, we learned how to translate from one to the other. So here I've just written 7 raised to the power of x equal 80. I've now turned that into a logarithm. That's log base 7 of 80 equals x. When I have something of this nature on the left-hand side, this is where we can use the change of base formula. Or I can write log base 7 of 80 as the log of 80 over the log of 7. Those are things I can do on my calculator. Recall here that log without a base means log to the base of 10, which corresponds to, as I bring my calculator over, our good little log friend there on the calculator. So in any case, I can move forward. Log of 80 is 1.90. Log of 7 is 0.845. That's equal to x. Taking those two values and summing out, or dividing out, I get x is about 2.25. Now the second way that we can work with this is to go ahead and take the log on each side first. A little different approach, we're going to get to the same place. So 7 to the x equals 80, that's where we started with. Now I'm taking the log on each side. So the log of 7 to the x equals the log of 80. Do unto one side what you do unto the other. From here on the left-hand side, I can use the power property. I add log of 7 to the x. That's the same thing. Remember, we say pull the exponent out when you have something like this. It becomes x times the log of 7 equals the log of 80. What's my next step? Well, I want to solve for x, so I'm going to, on the left-hand side, divide both sides by log of 7. So what do I wind up with? X equals the log of 80 over the log of 7. Looks pretty familiar to what I did with change of base, doesn't it? When all said and done, 2.25 is my final answer. I'll work through another problem. This is a little bit more complicated. It also came from the notes packet. But we'll find out that after a little bit of work, it's pretty straightforward. 12 plus 5 to the 1.07 x power, for the camera move, equals 80. Okay, just do some simple algebra. Subtract 12 from each side. So 5 to the 1.07 x equals 68, 80 minus 12. Next step, clean on both sides, divide by 5. So, dividing left-hand and right-hand side both by 5, 1.07 to the power of x equals 68.5. Okay, what's my next step? Well, in this case, I'm going to go ahead and just say I'll take the log of both sides. So log of 1.07 raised to the x equals the log of 68 over 5. Power property comes immediately into play now. So x times the log of 1.07 equals the log of 68 over 5. Key thing here, that's not the log of 68 over the log of 5. It's the log of the fraction 68 divided by 5. Over here, I've already gone ahead, just went to my calculator and got these two values out. The log of 68 over 5, the log of 68 divided by 5, is 1.11. It turns out the log of 1.07 equals about 0.029. Now what have I done next? I've just taken those values and brought them into my equation. So x times 0.029 equals 1.11. X equals 1.11 over 0.029, and that'll give me 38.28 as my final estimated answer. So those are a couple problems out of the notes packet. I'm now going to work from a couple problems out of the gold sheet. These are the sheets that were handed out on Blue Day on the 9th, and on Gold Day they came out on the 10th. So the first problem I'm going to look at is problem 8 from the gold sheet. That is 8 to the negative 2x equals 26. Again, I'm going to use two methods for this. First, I'm going to just use my rewrite approach. That's a dog barking. Don't worry about that. They get excited about these problems sometimes. So what I'm going to do is 8 to the negative 2x power equals 26. That's the same as log base 8 of 26 equals negative 2x. What's my next step? Left-hand side, change of base. So log base 8 of 26 is the same as log of 26 over the log of 8. Again, I can do these on my calculator. 1.41 and 0.903 are the two appropriate values, and that's going to be equal to negative 2x. Moving down a little bit, I got 1.41 over 0.903. That becomes 1.56, and that's equivalent to negative 2x. How do I solve for x? Divide both sides by negative 2. So x equals negative of 1.56 over 2, or negative 0.78. Second method, I'm going to take the log of each side, and let's see what I get. Log base 8 of 8 to the negative 2x equals the log of 26. I've taken the log of both sides again. What's next? Power property. Log of 8 to the negative 2x power is the same as negative 2x times the log of 8. Back to algebra mode now. Negative 2x, divide the log of 8 on each side, or divide each side by the log of 8, excuse me. So I wind up with negative 2x equals the log of 26 over the log of 8. Calculations just like we had before, negative 2x equals 1.41 over 0.93. That gives me same thing as above. Isn't that convenient? Negative 2x equals 1.56. Finish solving through. X equals negative 0.78. The final problem, just one more that we'll do, a little bit more complicated, but certainly workable. We have 3 to the power of x minus 7 equals 1/14. On this one, I'm going to just go ahead and attack this with logs. So log of 3 to the x minus 7 power is the same as the log of 1/14. Power property, always power property when I'm following along this step now is going to apply. So it becomes x minus 7 times the log of 3. I pull my power down, x minus 7. So x minus 7 times the log of 3 equals the log of 1/14. Dividing both sides by log of 3 gives me x minus 7 equals the log of 1/14. Notice how I've kind of put that in parentheses now just to show that that's the log of 1/14, that particular fraction, divided by the log of 3. Last piece, at least from an algebra standpoint, well, if x minus 7 equals that, to get what x is, I need to add 7 on both sides. So my next step, and I'll go ahead and clean up a couple signs here with my marker as I work through. So I will wind up with the log of 1 over 1/14 over the log of 3 plus 7. Do a little bit of work with my calculator. I have negative 1.146 over 0.477 plus 7. That fraction turns out to be negative 2.40 plus 7. And so when all is said and done, my answer is going to be right around, again, this is a little bit of approximation because of the logs here. My answer will be approximately 4.6. So there's the process. Give it a shot on your own. I think you'll feel very comfortable. It's a repetitive process. Working it over and over, this same style will get you where you need to be.